Just to remind you guys, I said this last time, but every test day I'll be in the office at 7, so I'll be in there earlier. And we don't start the test right away. There's like a buffer of, I can't remember in the syllabus, I said like up to 40 minutes or something before a test for questions and whatever. Everybody with me? So if nobody has questions, we'll start the test like right away. If you have questions, we'll go up to a certain point, and I'm like, that's enough, take the test. Okay. Where's this dude? There he is. Okay. So let me catch up with you guys real quick. What you guys get? Read this off to me so I don't have to.
92, 73, 11.
Thank you. Right. And then these two?
26, 50.
Okay, cool. Let's do 6 total. I like it. So pretty much always going to give you those blank boxes, right? So that maybe hopefully it spurs your brain if you forgot what the hell to do. You're like, why are those blank? I've got to fill them in. Attends Grossmont. 55 chances out of... You guys all right? That's not right. Where did you get 55? Oh, I see. So how many people attend Grossmont? 126 out of 176. I wish you could say that. I did that on purpose, but I didn't. What do you guys get for that, by the way? What is that? 4 decimal place.
0.7159. 7159.
0.7160.
Well, I got the century. I think it's 7159, right?
Yeah.
So you gotta be careful, man. Is a business major.
92 out of 2.
Yeah, 92 chances to get one out of 176. And if you're still somebody, I saw a few people doing this, if you're still somebody that thinks it should be 1 out of 92 or something, just remember, if you're trying to go for a red poker chip, and I'm like, do you want me to put more red poker chips in? I'm like, well, yeah, it's going to increase my chances, my probability. So that's why it's all about the number of chances to get a match. So that's why that 92 is got to be 92 chances to get a match out of 176 things, right? Okay. Here's an OR, which means basically add. So if you do the computer science majors, 73, and you add the Grossmont students, you better do what also?
Subtract the...
However many is both. I like it, because I would have added them twice. So then you get 137 out of 176, which is whatever. What is it?
7, 7,
7?
7, 8, 8, 4.
8, 4. All right, thank you. Everybody messes this up somehow. Not everybody, but too many. You either try to use a formula, which is kind of crazy in this. I would not use a formula for any of this, right? This is much more straightforward. Just remember, and is very restrictive. You must match all the requirements, so the number is going to get small. How many people match both of these things?
2.
Just 2. In fact, and is the intersection. Intersection of Quimaca and math is 2. So 2 out of what?
176.
What's the only problem up here that's going to have a different bottom? Probably the only one left. Because it's a given, yeah. I'm not going to change the bottom unless I'm given more information. I can eliminate possibilities then. I don't know shit here. I can't eliminate any possibilities. And whatever this is.
0.0114.
Is that right? So here, given their computer science major, so what goes where because of that? Given their computer science major.
62 over 73.
Well, it's 73 computer science majors, so out of those 73 computer science majors, 62 go to Grossmont, 62 out of 73, and that's
8493.
8493. And I like, somebody brought up this and right here. I gotta work with the English language. So and doesn't always mean and, right? It's just, are this and this independent? So how do you check that? Well, you can never check the probability of this versus the probability of this, because that has nothing about how they interact with each other. I have to have a piece that talks about how they interact with each other. That's this dude. So probably their gross bond student is like almost 72%. If I knew that person was a computer science major, then probably their gross bond student
Increases.
goes way up. So knowing their computer science major affected the chances they're a gross bond student, therefore they are
Dependent.
not independent or just dependent.
Wait,
Right?
can you say the last name real slow?
I was going to be real Jack and say, the last thing. All right. I don't know what the last thing was, but since knowing their computer science major, which is what this is all about, changed the probability they're a gross bond student. These two are dependent. What's the probability they're a gross bond student? Well, it depends on if I know their computer science major or not, right? Doesn't it? If I know they are, it's this. If I don't have a clue, it's this. So does that probability depend on me knowing the other thing? Yes. So thank God we chose to call that dependent. Now what would I want to see here? That's the question I would think you'd have.
In order for them to be independent, they would have to equal each other.
They would have to exactly equal each other.
Okay.
Yes.
Could that ever happen by chance?
Some things, yes.
But if they did happen by chance, would that make them independent? Or
Then you
would
want to
that
get, and again, most of what we learn in this class is surface level first step stuff. Then there's deeper analysis that you would learn later this class, and then maybe stats 2 and 3, which we don't teach here. So I wish we did. That'd be awesome. And you guys are like, this is enough. So what would I want to see here? The probability of gross bond student does not equal the probability of gross bond student given computer science. 0.7159 does not equal 0.8493. Dependent. Circle. Done. So people hear that word dependent and they'll say stuff like, well, you don't have to be a computer science major to go to gross bond. That's not, no. Dependent in this case means it affects the probability that you're a gross bond student. So listen to this example. And this example I've gotten in trouble for before, which is probably why I like to do it over and over and see how much trouble I get in. Nothing too bad. You see somebody off in the distance walking towards you. They're really far away, right? And they got kind of long hair. It could be a man or a woman. I have no idea yet. Are you guys kind of with me? All right, so it's probably it's a man. 50%, thank you. Right? And to be honest, it's a little more than 50, but it doesn't matter. So roughly 50%. What if you also realized they had just gotten off of a Harley Davidson motorcycle? The probability they're a dude is it's still 50%. I love some of you guys are like, are you trying to say something? The probability they're a dude went up, did it not? And I'm not saying a damn thing about no women, but no. This is all probability talk, right? Am I saying it can't be a woman? No. The probability it's a dude went up. Why? People that ride Harley Davidson, they're normally men. I didn't say there's no women that ride. I remember one semester some girl, I ride my, oh. It's probabilities, right? I didn't say what the truth was. I said what the probability is. Sorry. Somebody had...
Yeah, if they have long hair, wouldn't their probability of being a woman be higher than 50%?
Yeah, but I was trying to give us a reason why I would think I wouldn't know. But they're just so far away, I'm not even going to say long hair then. They're just so far away I can't tell yet. Right? And they're wearing nondescript clothing, whatever. My eyesight's bad, as you know. I'm only using this eyeball, so I can't even tell what any of you are with that eye. All right. Does that sort of make sense? I mean, I want you to realize this doesn't say anything about what is really happening. It's just talking about the chances of what's happening. So don't say, you could be both. No. Does the probability change if you know this thing? Yes, you can see it. And see how many words that I use in my answer. 1, right? The more words you use for that thing, the more likely you are getting it wrong. Yeah, this is a mathematical idea. And actually, it's not just a mathematical idea, but it is easily captured by comparing numbers. And I will pretty much always have you do the work you need just to go find it.
Do we need to put the numbers up there, or are you okay with us just writing?
You need to put the numbers up there.
Okay.
Yeah, thank you. Because otherwise you just memorize what to put here and you're like, you don't even check the numbers. I don't know if that's happening. Yes.
Would we get it wrong if we did it for the formula? If you just put the numbers instead of.
I need to understand what those numbers mean. If you just say this number didn't equal that one, I'm like, ooh, that's ground shaking, right? Right? By itself, that's like, okay. But you did that because they are these. And that's the idea of independent, and they're not equal, so dependent. Okay. Woo! I like this one. I just want to leave them all in the damn house. Person, probably that person we pick is a Democrat. I'll just do this real quick. I think everybody got this based. Three. Republican, there's 12 of them. And what's that going to do? I don't know.
5, 7, 1.
Thank you. I ran out of my mojo today. Now we take 2 people. So what I like to do for these kind of problems, I'm going to have like 2 blank spots with a multiply in the middle, right? I got 2 people, this and this. What's the probability that the first thing happens?
2.
Yeah, 2 out of 21. Put that person back in the house. Probably take him out, thank you, and then I put him back in. Oh shit. And then what's probably the next thing happens? Yeah, everything stays, all the numbers stay the same. There's still 12 Republicans, still 21 people, because I did it with replacement. And then whatever the hell that is. And you're not going to help me, that's all.
0.0544.
Okay. 0544.
Yeah.
All right. 2 Democrats. So they're both just going to be what? 7 out of 21. And that is 0.1111. Ha! Sorry. All right. Get Luke. Now we do, see how I do this all the time. I ask the same exact question, but it's without replacement. So the neat thing is, the only thing that's going to change from that stuff up there, what's going to happen here that's different.
And the answer.
Yeah, at this point I picked 1 person, now there's 1 less person, but there's still 12 Republicans. So the chances the first guy is an independent, 2 out of 21, I let him leave, or her. Times. Still 12 Republicans, but now there's only 20 people. And,
0, 5, 7.
0571, kick it. And of course, this one, the only difference now is, so 7 out of 21 chance still for the first guy or girl. Let that person leave.
And then 6 out of 20.
Good, there's 1 less Democrat, 1 less person.
Point 1. 1, 7, 1. Oh, it's point 1.
It's got 0.1.
Yeah, that's right. 1/3 of 6 is 2. 2/20 is 10%. Yeah. Okay, I like it. All right, let's get to the weird one. The one about chocolate milk and
Did you watch
Brussels
the
sprouts.
stats?
Huh?
Is the stats?
That's a
related to
true.
kids?
That's a true reference. I don't know if anybody heard of that when it came out, but if you look at the survey, the questions they asked had some issues. So this doesn't necessarily mean that 7% actually believe this, but I'm just going to go off of the results of the survey, and I made this just to let you know that it existed. And if you go look it up, you can see the issues that the survey had. If you put a survey together and you're not careful with how you word things, you're not going to get the information you want. So this is a beautiful example of, thank God that we're not quite that dumb. What's some chocolate milk? That cow. What's some strawberry milk? That one's got a red tinge. So, thankfully, it's smaller than that, but unfortunately, it's probably not 0. But assuming that's true, here's the difference between this problem and this problem. We had to come up with our own probabilities by writing these ratios. I like it. Now, if there's somebody who did this you don't have to do that because it's not going to become out of 99 for the next one because there's not 100 Americans, right? So here's the thing. Somebody help me out. So there's like 340 million, I think. 380, I don't even know where we are now. So somebody help me out. What's like 10 divided by 350 million? Ah. So let's see. I don't know what that was, but it just happened.
Listen.
Yeah, oh my God. So it's like 2.857 times 10 to the negative 8. This is what that means when you see that in your calculator. Times 10 to the negative 8. Good old scientific notation that you all know. Oh shit. Okay. Now watch. What if I lose a person? So make this 10 out of 349,999,999. Yeah, it's going to be basically then divided by 349,999,999. See how they're the same all the way up until there. So I would say they're the freaking same, right? Okay, so when your population, and what population am I talking about in this problem? Can anybody? All what?
All Americans.
Americans. Is that a large population?
Yes.
Yes. Then I don't have to write ratios of shit because as they change, they're not going to change by much at all. So I can just do this. 1, 2, 3, 4. 4 people, right? The first dude thinks this is true. So what's he get? A low grade. Yeah, 0.07, 7% chance. The other ones are all going to be what? And you're just going to multiply those because it's this guy thinks this and this guy thinks this and this guy thinks that. And then whatever the shit that comes out to be. I guess it's not going to help you. 0.56. 3. Okay. All right. Yes.
Which is the multiplication, which is the subtraction.
This is all times. Why is it all times? Because I'm wondering the probability this guy thinks it's true, and this guy doesn't think it's true, and this guy doesn't think it's true, and that's why they're connected by multiplication. I like it. Yes?
Where did we get the 93 from?
If 7% think it's true, 93% don't.
Oh, okay.
Yeah. Right? Okay. Now this is a neat question. If the probability is going to rain today was 5%, what's the probability it's not going to rain? 95%. So if I can figure out the opposite probability of something. So if somebody asks me a question and I figure out the probability for the opposite of that question, I can do 1 minus what I got to answer his question. 2 opposite probabilities, one will be 1 minus the other one. So any damn time that the opposite of the question is easier to do, shit, yeah, I'm going to do that. And then just do 1 minus what I get. Now, let me show you why this is not an easy question by itself. What does at least 1 mean? So 1 or 2 or 3 or 4, right? And what's probably that one person thinks this? You're wrong. So it could be the first guy, which is that probability, or the second guy, or the third guy, or the fourth guy. So we do all that work, but it's at least 1. So it could be the first 2 would be 0.07, 0.07. Or maybe it's the last 2, or maybe it's the middle 2, or maybe it's the first one and the last one, or maybe it's the first one and the third, or maybe it's the shit. And then I haven't even done 3 yet. I really want you to understand, at least 1, how many ways is there to do at least 1? There's a ton of ways. Thankfully, there's only 4 people, but it's already way too much freaking work for me to do that. What's the opposite of at least 1? All is the same as at least 1. All is included in it. None. If I said at least one person in here likes liver. How would you show I'm wrong? The only way you can show that I'm wrong is if none of them there. So those are opposites. So let's do the probability that nobody thinks. If I do this, if I can figure out this and subtract it from 1, I'm going to answer the question. So if I get the opposite situation, subtract it from 1, I'm going to answer the question. It's crazy. Yes?
If you were to do, because the only situation where it would be one person is if it was literally just one person and then the rest believed it. So could you do
But
it
there's
that-
4 of those.
Yeah, so could you do it if you did like 7 out of 100 times basically the same way because there's only one and that's like the least
But then
amount.
that's only 1. At least 1 means 1. So that's got 4 parts. Or 2. Or 3. Or 4. Right? So watch this. So I got 4 people, right? And let's say thinks that way, doesn't think that way. Is that cool? Thinks it's true, doesn't think it's true. So at least 1 would be the probability of 1 plus the probability of 2 plus probability of 3 plus probability of 4. All right, probability of 1 would be the first one thinks it's true, the last 3 don't. Or it's the second guy that thinks it's true. Or it's the third guy that thinks it's true. Or it's the last guy that thinks it's true.
I like that because like you're multiplying, it doesn't really matter where you place it.
How do you answer a probability question? You have to add up all the ways that match what you're looking for. Is this a situation where exactly one person thinks it's true?
Yeah.
This also is. So how can I have one person think it's true this way, or?
But if you do say, for example, like 5 times 7 times 7 times 7, and then you
I
switch them.
know. But you got to do it all the ways and add them up to get the total probability.
Oh, okay.
So you're right. Mathematically, each of these are the same number. So I could take the number and multiply by 4, but I'm not done yet, right? Because I haven't done 2 yet. And 2 could be like that, or like that, or I'm going to stop very soon because, or like that, and I'm not even done yet. And then 3 would be TTTD or TTDT, or I want you to realize this is why, thank God, we know that probabilities add up to 1. Opposite probabilities add to 1. So if the question they ask has too much work to do, I'll think about what's the opposite of what they ask.
They all don't believe.
Huh?
They all don't believe.
Yeah, there's only one way to do this, right? There's only one way to do this. None of them believe it. They all don't. D, right?
So would you do 0.93 basically times 0.90?
To the 4th power even. I like it. So, what do I do with you very much? So if I just do this, 1 minus 0.93 to the 4th power. Uh-oh, can I push that? Is that all right? It'll be 0.93 times 0.93 times 0.93 times 0.9. So I have 4 that don't think that's true. So that's the opposite of what the question wanted. So the question's all angry. You ain't answered. And there you go, question. 1 minus that is going to be your answer now, whatever that is. 0.25, 19? Sounds about right. 25% chance that at least one of them thinks chocolate milk comes from brown cows. Yes? Are you guys trying to make me feel like I'm losing my hearing? What is it? Are you alright?
Why couldn't you have done like
That's not the answer though. No. You are lucky that it came out
That's just-
close.
that's just- okay.
Because if I made that instead of 0.93, if I made it 0.82, it ain't gonna come out to be 1 out of 4 yet. Do you notice how these probabilities are not based on 4 people being picked? If I picked 18 billion people, which I can't, if I picked 300 people, would that 7% change? No, 7% of Americans think that's true. It doesn't. I don't care if we know that. Then I go pick some people. Does that number change? No. So the probabilities are not dependent directly on how many people I pick like that. It's that number used for the number of people I'm talking about. Yeah, so the 1 out of 4 means nothing here. Okay.
Wait,
Oh.
so that means that what the population believes can't be used on a sample, the sample believes can't be used on a population.
No, it's nowhere near what I said. The number 4 has nothing to do directly with what the probabilities are involved. I'm told 7%, so I know the probabilities are 7% and 93%. I know that going in. 4 tells me how many blank spots I got. That's all it does. So 1 out of 4, 2 out of 4, 3 out of 4 doesn't mean anything here. Right? I just have big numbers that made it come out close. And I hate when that happens because then people are like, oh, maybe no, yeah, you know. Anything else I put here, that's gone. That's shit, right? Okay, maybe. So what about this last one? If we also know that 4% of Americans think that chocolate milk comes from brown cows, and Brussels sprouts are the best vegetable. So let me put that in symbols. Probability that they think that, right? That's the symbol I use for thinking that it comes from brown cows. Is that cool? So let's just do this. This is 0.07, right? Cool. This is, can I just use B for Brussels sprouts? Or the best vegetable? All right, so I've just summarized kind of like what I know here, right? And this is the importance of picking good symbols. What's the question asking me then? Can you write in symbols what the question is asking me? Find the probability that they like Brussels sprouts, given that they think chocolate milk comes from brown cows.
So P or T.
What goes here?
B.
B.
Given sign T.
Yeah. So given that they think T, what's probably Brussels sprout B? What's the formula for this? Uh-oh. What goes on the bottom?
PT.
Yes. And what goes on the top?
PB and T.
Don't I know both of those?
Yeah.
Yep. That's 0.04. That's 0.07. So there will be situations in the homework and the test where you giving yourself symbols to use and then writing those symbols in the formula that I asked for, and then you know where to put stuff. Now that I picked symbols, I wrote the formula, I know exactly where stuff goes. 0.04 on top, 0.07 on the bottom, and that's like 5, 7.
1, 4. 1, 4.
Crazy. All right. Let's do the formula sheet real quick, and then I'll open it up to that crazy amount of time we have left for any other questions. Yes.
Just like, are you making a formula sheet
For you to use on the test.
Okay.
Yes. By the way, you will lose points. I'm sorry, did I respond to that too harshly? I just want to make a point. Formula sheets, if you have stuff on there that I don't say you can have, you will lose points for that. If you have something that I didn't let other people have, you will lose points. And if you make little marks that I don't know what they mean, you will lose points. Because I have people that are very creative, make little languages for themselves and little symbols that mean things, and I'm like, that's nice, -4 or something. You know, come on. Okay. You made your own language. Great. -8. All right. We don't really have a lot of formulas, which is nice. You don't even have to, if I were you, I might not even put these down. Right? But it might be good to remind yourself. Now, for example, you can't put population here, right? This is oh good, I've already got these here. These can be in your formula sheet. Yeah. You don't have to write them down again.
Can we write mean?
No. Sorry. I'm being really evil in my responses. No. That's worse. No. You can't have any words except for maybe a couple that I specifically say you can have. You can only have formulas. So I don't make you memorize them, I make you recognize them. Yes? No, okay. Then we have this guy. And of course we have this guy. Is that cool?
For and, we don't feel like and has,
Oh, I forgot and up here. Because I did that one earlier, but it was over there. But go ahead.
You know how it has its own reason, you know, weird.
Do they use that in the book, this?
No, not that one. Like,
Oh, you mean like,
kind of like that one.
yeah.
Yeah.
That's the way you write an ampersand, is all the curly shapes are part of it. I don't, so obviously you can have the word and here on your formula sheet. Alright. You can have this one. Alright, for that z-score thing. I think that's basically everything. I haven't really done a lot of formulas yet. Yeah, I see.
oh,
What's up?
sorry,
I like it. You can. I was thinking about whether or not to say that. If you also want to put, like, next to this one, or underneath it, with a big ass square root symbol. That's fine. So you can remind yourself that this is part of the process. Because this, of course, is the variance. You have the square root to get the standard deviation because we've got to kill those squares we did. Yes?
Should we write like the IQR or like percentile for like thing for outliers or no?
No. Because those are ideas.
The R squared, that would be for population.
Sigma squared. Yes.
Oh, yeah, sorry.
Population. That's right.
Sigma squared, that would be for population. And S squared is for sample. For sample.
So right now, the Greek letters are population. Our letters are for samples. Yeah. Doesn't hold true forever, but for right now, it's kind of what it is for what we know.